In this video, we'll try to understand what is WPF and why do we need WPF. So let's first start with the full form of WPF. WPF stands for Windows Presentation Foundation. WPF is nothing but it's a graphical subsystem by which you can go and display user interfaces in Windows application. So the next question which you would ask is basically, why do we need one more graphical system when we already had Winforms? If you remember, right, you can always go and create a project in Winform, which will help you to create user interfaces for business applications like this, right? So when we already had Winforms, why do we need one more graphical system like WPF? And the reasons are A, B, C, D, E, F, and G. So let me go through each of these reasons step by step so that you can get convinced that WPF is far superior than Winforms. So let's start with the first point, A, anywhere execution. Anywhere execution means, you can create your UI once in WPF and then you can run it as a Windows form, or I'll say a Win application, or we can run it as a web application. So now you must be wondering that how it is possible to execute WPF application on multi-platforms. If you go and create a WPF application, so you can see here what I've done is, because we are doing the comparison with Windows also, I have created two projects here. One is a Windows project and the other one is a WPF application, right? So if you go and see a WPF application UI, right? Now, if you want to create a WPF application very quickly, you need to go and use the WPF application template. So by using this template, I have created this UI over here, which is a WPF UI, right? Now, if you go and see the WPF UI, now there are two parts to it. One is you can see that we have a XML here. This XML is termed as XAML. You can also see the file notation or the file extension here as XAML. So this XML is read and rendered as a WPF UI. In other words, the internal representation of WPF UI is XML. Now, can you think, why is the internal representation as XML? Think about WCF services, why they use XML. Think about web services, why they use XML. Absolutely right. XML is used, when you have two systems, which are heterogeneous in nature. So for example, in WCF services, you have C# at one end and then you have Java at other end. That's why you use XML. So here also they have kept their internal representation as XML so that they can create the UI once in XML and then they can render it on a Win application or on a Windows platform like a exe, or they can run it as a web application inside a browser. And on the other side, if you see a Winform form, so if you go and open a Windows form, and if you see the internal representation of the UI, it is a C# code, it's a C# object, right? So it's very difficult now to take this C# object, this UI object, and you can see this UI object is very specific. Again, you can see it is saying system.windows.form. So I don't know how I can take this behind code and I can port it into a web application, right? So here, in WPF, the start itself is very great. It's awesome that their complete internal representation of your UI, of the UI, is in a XML format. So they can take this XML format and then run it as a Winform, or they can run it as a web application. So let me show you a small demo here, how this whole thing works. So you can see here I have selected this WPF application, and if I run this, if I do a Control F5, I see the screen here, right? So if you want to go and move this to a web application, what you can do is you can create a WPF web. Okay, so if you go here, so let me go and add a project. So if you see, there is a project template here called as WPF browser, or you can also term it as WPF web. Okay, so you can go and create a WPF browser application here, right? Now you can see I have copied that XML code, for the buttons and the text box, and I'm going to just go and paste it over here. So I'll just say Control V, and if I now go and run this, now this is a WPF browser application. Okay, so if I do a Control F5 now, you can see that the same screen is now running inside the browser, right? here is my WPF WinForm application. So you can see this is my WPF browser application or WPF web, right? And this is my WinForm application, right? So the top one is the browser. You can see the browser here, Internet Explorer, and this one is my Windows, my WPF Windows application. So because our internal representation was a XML format, so this XML format is read and it can be rendered in any platform now. So the renderer, the WPF renderer can run and render this UI on a web as well as on Windows. So this is the first big point of WPF which I like: anywhere execution. You write the XAML once and then you can run it on your web application as a web application or as a Windows application. Now the next thing which makes WPF better than WinForms is B for binding. So let us go into more details on the bindings. Now when we talk about WPF applications, WPF application will create objects, and at some moment of time these objects would like to communicate with each other. In other words, they would like to send data or they would like to receive data from other objects, right? For example, you can see on the screen I have two text boxes, and there can be scenarios where I want these two text boxes to communicate with each other. For example, when I type on this text box, I would like the data to be sent to this text box, and when I type on this text box, I would like to send data to this text box. So in other words, both of them are objects at the end of the day, and they would like to communicate with each other. Now if I want to implement this in WinForms, then I would have to go to the text change of each text box and set data to the other text box. In other words, a lot of coding, right? But here in WPF, you just go and you set the bindings and it is done. So for example, over here now, let's say that this is text box 1. Okay, so one of the text box is text box 1, txt1, I'm sorry, and the other one is txt2, right? So what I can do now is I can go to the properties of one of those text boxes. So for example, let me take the left hand text box here, that is txt1. So I can say that I want to go and bind the text property here. So I want to bind the txt1 property, text property, to the other text box. So you can see here I'm saying I want to bind the text property of txt1 with the text property of txt2. So txt2, right? So you can see here at the top, txt1 text will change when txt2 text will change. Why? Because I'm creating a binding between them, and I'll say okay. Now if I go and run this application here very quickly, so if I say Ctrl F5 here, so there our application is running. So now if I say here like text1, so this data of text1 which I've written gets updated to text2. If I say here like text2, you can see how it is updating text1, right? So you can see that by just setting simple bindings, I'm able to establish connection between both of these objects, right? So again, this is one more big advantage of WPF over Windows, that you don't have to write too much code, and you can just set the bindings and establish the connection between two objects. Now again, when I say objects, it is not just text boxes. Probably you would like to connect these text boxes to a customer object at the back end, right? So even that is possible with bindings. So first benefit of WPF, anywhere execution. Second benefit of WPF, bindings. Now the third benefit again of WPF, or I'll say advantage of WPF over Windows, is common look and feel. C, common look and feel. So A, anywhere execution, B, bindings, and C, common look and feel. So what exactly is this common look and feel? Now let's say if you want to go and set a common look and feel for your buttons and text boxes. For example, let's say that you want to go and say that all of your text boxes in your Windows form should have a background color of blue, right? So in WinForms, you cannot go and define a common look and feel and then apply over here, right? You have to go to every text property. So in other words, you have to go to every text property here, go and set the background color for each one of them, right? Which is tedious, right? So in WPF, what you can do is, very quickly, in WPF, you can go and create something called as styles. So you can go in WPF here. Okay, we are going to go into styles later on in depth, but for now, I'm just trying to make you understand the important advantages of WPF over WinForms. Okay, so we are going to have separate topics on styles, separate topics on bindings, right? But this lecture, I want to just I want to just ensure that you understand how WPF is superior than WinForms. So like I can just go and create a style here. So for example, I can go and create a style here. I'll explain all the style syntaxes later on. So you can see now I'm saying here, the font size of the text box should be 14, the height of the text box should be 40. When I move my cursor on the text box, I should see a hand, right? So I have defined a common look and feel here. Now what I can do is, again, I can go to my text box here. Okay, I can go to both of my text boxes and I can say F4, so properties, and I can say that can you go and bind the style of these text boxes. So very quickly, can you go and bind the style to the style which I've just created. Okay, I think we can bind style in one go. So let me go one by one. So I can go here and say F4 and say that, okay, I want to go and create a data binding which will actually go and, so I'm going to go and apply a style to this text box one here, txt1 first. So there it is. So I'm going to take this basic style here, apply over here. Then again, I can go to the other text box here and say, okay, again F4 and apply the style here as well, right? So you can see like I have created the style once and I'm just going and applying them to all my controls here, right? So there it is. So this is I'm applying to txt2 here. Say okay. So now if I go and run this application, you can see now the height of the text box, the font of the text box, they are looking very similar. And if I do a control F5 here, I should also see a hand of a cursor. So very quickly, so there it is. So you can see now when I move my mouse, it is showing a hand. Also you can see the font size is set in a standard way, right? So again, this is one more big advantage of WPF over Windows. If you want to go and create a common look and feel for your controls, you can just go and create a style and then start applying them to every control. While in WinForm, you have to go to every control and set the values, right? Right. So A for anywhere execution, B for bindings, C for common look and feel. The fourth thing, which is again very interesting in WPF is declarative programming, D. Okay. D for declarative programming. What do I mean by that? In declarative programming, you describe in an abstract manner how your code looks like rather than writing the actual code. For example, if you have noticed till now, I did demonstrations on bindings, I did demonstrations on styles, but I have not written a single line of code. For example, when I did demonstration on the binding, where one text box value was set to the other text box and this text box value was set to this text box, right? I did not write a single line of code. So how did it happen? It was happening because of directive programming. In other words, when I was setting those properties of binding to the text boxes, at the back end, Visual Studio was doing directive programming. For example, when I set the binding of the text boxes, you can see over here, I'm highlighting the code here. Now this is a directive XML. So in other words, without writing a single line of code, I'm expressing what I want to do. So it says here that the text1 text box text should be set to text2's text. So you can see that without writing a single line of code, I am able to express what I want to do, and he just does it. So this is again a very big achievement of WPF, directive programming. So in other words, we can expect that our development can become faster because we have to write now less amount of code. So A for anywhere execution, B for bindings, C for common look and feels, that is styles, D for directive programming. So now let's take the next one, E. E for expression blend and animation. Animation is again a big plus point for WPF. if you see the architecture of WPF, or if you see the way WPF works internally, it uses DirectX. Now DirectX is a nice framework for doing animation. So because DirectX can do animation, even WPF can do animation. And by using expression blend is nothing but it's a tool. So by using expression blend, we can go and do our animation, and then we can reuse that animation in Visual Studio. So again, this is a big point here. So for example, I can just go and write animation here. So you can see I have pasted animation here. We'll talk about animation in depth later on. But for now, you can see that what I've done is I have a label here, and what I'm trying to do is I'm trying to modify the label font size. So you can see here I'm saying add double animation, and I want to modify the label font size from 0 to 2000 with the value of 10. So in other words, with steps of 10, right? So if I run this program here, you will see that the label font size increases from 0 to 2000 with a step of 10. So you can see this label font size becoming bigger and bigger by 10, and with a duration of 3 seconds, right? So that is again a very big plus point of WPF. You can go and create animation by using the expression blend tool, and then you can go and write animation in a very simple directive way, right? So A for anywhere execution, B for binding, C for common look and feel, D for directive programming, E for expression blend and animation. Why? Because WPF uses DirectX internally. F for faster execution. So you must be wondering why WPF is faster than Winforms. WPF internally uses DirectX, while Winform internally uses GDI or GDI plus, I'll say. Now, because WPF uses DirectX internally, DirectX has the capability to do hardware rendering, while GDI does only software rendering. So the next question is, what exactly is the difference between hardware rendering and software rendering? Now, there are two ways by which a computer renders display on the monitor. First, by using a CPU, and second, by using a GPU. So in case of CPU rendering, the CPU drives the whole logic of how to render a display on the monitor. Now remember that CPU also does a lot of other things. For example, he runs the application, he does memory management, he runs your operating system and whatnot, right? And on that top of it, you have loaded him with extra work of also displaying the things on monitor, right? So that's where this extra guy GPU was plugged in. GPU stands for graphical processing unit. GPU is nothing but, you can think about, it's a specialized kind of processor which is specifically meant for rendering and display. Now the GPU is specifically meant to render your displays faster. That's the whole point of GPU. So this GPU actually takes the whole load from the CPU about displays and tells to CPU that you take care of memory management and application running. I will take care of the display part, thus making your CPU free for doing other things, right? Now the CPU way of rendering is called as software rendering. The GPU way of rendering is called as hardware rendering. Now when you use WPF, right, and when it comes about rendering these controls on the screen, it will try to use the GPU. In case it does not find a GPU, then he will switch to CPU rendering, okay? But when it comes to Winforms, Winforms or the Winforms use GDI internally, and GDI purely uses CPU rendering. Must be there are some cases where it uses GPU, but most of the time it uses CPU rendering, which means that the time your GPU starts taking the load of rendering and your CPU becomes free, your application has to run faster, right? Because now the load is shared between two hardwares, right? One is specialized for display, and the other one is specialized to run your application. So WPF uses hardware rendering internally, and thus making your application faster. And WPF goes one step further. This rendering is further optimized into tier 0, tier 1 and tier 2 mode. Tier 0 mode means pure software rendering, because must be that you don't have a GPU or you don't have that card for display. So you will purely switch to CPU rendering. That means it will use DirectX 7 internally. If he sees that some of the functionalities can be done better by GPU and some of the functionalities can be better done by CPU, then he will switch to partial software rendering, or you can say partial hardware rendering, okay? And the last one is tier 2, where it switches purely to hardware rendering, and that's where he uses DirectX 9. So if it is pure software rendering, if he sees that there is no GPU, he will switch to DirectX 7. That means pure software rendering. If he sees that some of the functionalities can be better drawn by using GPU and some of the functionalities can be better drawn by CPU, he will switch in between, that is between DirectX 7 to 9. And last one, when he sees that that there is a very nice GPU card, then he will purely switch to hardware rendering. That means he will use DirectX 9. So again, WPF is very smart enough, to switch between software rendering and hardware rendering depending on your hardware environment. So reiterating, so that you don't forget again and again: A for anywhere execution, B for bindings, C for common look and feel, D for directive programming, E for expression blend and animation, F for faster execution because it uses hardware rendering internally. And now G for graphic independency means what? So what do I mean by graphic independency here? Graphic independency here means resolution independency. So let me define first resolution. Resolution is nothing but the total number of pixels that fit into your screen, into your monitor, right? Now what exactly is a pixel? A pixel is nothing but it's a simple dot on the screen. So now if someone says that my resolution is 800 by 600 pixels on a 15-inch monitor, that means per inch there are 53 pixels. But now if you take the same 800 by 600 and if you say 19-inch, that means in 1 inch I have 42 pixels. So in 1 inch, if you have 53 pixels, that resolution is much better as compared to in the 19-inch, where you have 42 pixels, right? So resolution, if you ask to an end user, he thinks in terms of pixels. And most of the times you will see that the end user goes to his computer and actually he can adjust his resolution. So you will see that if somebody wants to make his resolution better, he will right click on the desktop, go to the screen resolution, and normally you will see that people fiddle around with this pixels over here, right? Now if your application is using pixels for doing alignment, doing measurement, right? That means if the end user goes and changes his pixels, then your application goes for a toss, right? The alignment goes for a toss, the look and feel goes for a toss. So if you look at Windows Form, right, Windows Form uses pixels as a measurement unit. So if the pixel changes, then Windows Form has to adjust himself. Again, that means you have to write logic for it. But in WPF, he does not use pixel as a measurement unit, but it uses something called as DIP, that is device independent pixels. So now 1 DIP is equal to 1/96th of the inch. So in other words, here WPF does not use pixel as a measurement or alignment unit, but it uses DIP, and DIP deals directly with a physical measurement, that is inch. So 1 DIP is equal to 1/96th of the inch. That means he is trying to relate himself directly with the physical length of the monitor. Okay, so that means if I change my resolution, right, it does not matter for WPF because he's going to use this 1/96th factor, right? So we'll talk about this graphical independency in more depth later on, but for now what you need to understand is that if I change my resolution in a Windows based application, then I will see the same screen differently in different resolution. But if I change my resolution for WPF application, you will see that WPF application almost looks similar, right? So just iterating, what are the benefits of WPF over Windows? Let's start. First, A, anywhere execution. You write the XAML once, you can run it as a Silverlight application, you can run it as a Winform application, you can run it as a WPF web application. B for bindings, where basically you can just take two objects, and if you want to pass data from one object to other object, you define a binding and the data just starts getting replicated between those two objects. C for common look and feel. In Windows Form, I have to go to every text box, every button, and if I want to make it a standard color, I have to go to every text box, every button and fix their colors. But here I can just go and define a style and then I can start applying. D, for directive programming. So, rather than writing a lot of C# code, you can just go and use the XAML directive and it will actually, run the code accordingly. So less coding as compared to Winform programming. E for expression blend and animation. So because WPF uses DirectX internally, you can just go ahead and write a nice directive animation, a directive XAML animation, and he will do the animation for you. F for faster execution. Why? Because now he can use hardware acceleration because it has DirectX internally. And hardware acceleration means you're going to use your GPU. So your CPU will be less loaded. That means, your CPU can do better work, rather than doing the display work. And finally, G for graphic independency, where WPF uses something called as device independent pixels, which is 1/96 of the inch, rather than using the pixels, which can be changed by the end user. So A, B, C, D, E, F, and G are the reasons, why you would like to choose WPF over Winforms. So I hope that you enjoyed this video. So this was just a starter video to make you understand, why WPF. And in the coming videos, we're going to go and run through like 15-20 labs for WPF, where you will get a better understanding of WPF. So I hope that you enjoyed this video. In this video, we are trying to understand why WPF is better than Winforms. Thank you so much.